Hi, and welcome to this special segment of Quick Maths that will look into the factorization of quadratic expression. Let's begin with what is factorization. In math, factorization converts a number or an expression into a product of its factors. For example, 15 is equal to the product of its factors 3 and 5. AB plus BC is equal to the product of B and A plus C. X squared plus x minus 2 is equal to the product of x plus 2 and x minus 1. And x squared minus y squared is equal to the product of x plus y and x minus y. Let me dwell on the factorization of integers. This is more likely to state an integer as the product of its prime factors. For example, 15 is 3 times 5. 120 is 2 times 2 times 2 times 3 times 5, and so on. Factorization is often used in fractions and ratios to assist with simplification to its lowest term. For example, 22 over 100 can be converted to its prime factors 11 times 2 over 5 times 5 times 2 times 2 to assist with its simplification to 11 over 50. Likewise, 72 over 306 could be individually made into their respective prime factors to assist with its simplification to being 4 over 17. For the factorization in algebra, it involves the conversion of an expression to the product of its common factor. For example, AB plus AC plus AD is equal to the product of A and B plus C plus D. Also, AC plus AD plus BC plus BD can be equated to the product of A and C plus D plus the product of B and C plus D, which in turn is the product of A plus B and C plus D. As for the factorization of quadratic polynomials, it too involves the conversion of an expression to the product of its factors. For example, x squared minus x minus 2 is equal to the product of x plus 1 and x minus 2, and 5x squared minus 18x plus 9 is equal to the product of 5x minus 3 and x minus 3. But they are difficult to chew on. This and the subsequent 2 slides are meant to assist you with making quicker work on the factorization of quadratic expression. Let's begin with the scenario of a quadratic expression ax squared plus bx plus c, where its a is 1 and the difference between its b and c values being 1. In such a case, its factors will always be a product of x symbol 1 and x symbol c, where symbol is either a plus or a minus. In column 1, the quadratic expression reads as x squared plus 9x plus 8. In this case, it fulfills a being 1 and the difference of b and c being 1. When c is positive and b is positive, both the 1 and 8 will take the symbol of positive. In column 2, when c is positive and b is negative, both the 1 and 8 will take the symbol of negative. In column 3, when c is negative and b is positive, only the larger number, which in this case is 8, takes the symbol of positive. And in column 4, when c is negative and b is negative, only the larger number, which in this case is 8, takes the symbol of negative. Next, we'll look at the scenario where a remains 1, but the difference between b and c no longer is 1. In such a case, its factors will always be a product of x symbol c1 and x symbol c2, where the products of c1 and c2 is equal to C. Again, as in the first column, when C is positive and B is positive, both C1 and C2 take on the symbol of positive. In column 2, when C is positive and B is negative, both C1 and C2 will take on the symbol of negative. In column 3, when C1 is negative and B is positive, the larger of C1, C2 will take on the symbol of positive. And in the fourth column, when C is negative and B is negative, the larger of C1, C2 takes the symbol of negative. In the third scenario, where A no longer is 1, but is a prime number, its factors will always be the product of AX symbol C1 and X symbol C2. Looking at its column 1, when C is positive and B is positive, both its C1 and C2 will take on the symbol of positive. Likewise in column 2, when C is positive and B is negative, both C1 and C2 will take on the symbol of negative. And in column 3, when C is negative and B is positive, the larger of C1 and AC2 will take on the symbol of positive. And in the fourth column, when C is negative and B is negative, the larger of C1 and AC2 will take on the symbol of negative. There are other forms of polynomials where A is not a prime number and A is negative, which I shall not elaborate, but they will appear in the coming tutorial questions. From here onwards, there will be 5 rounds of 4 tutorial questions for you to test your speed in performing factorization of polynomials. Each subsequent answer will appear after 7 seconds. So shout out your answer and compare it with what's on the video. Let's begin. Round 2. Round 3. Round 4. Round 5. That's all for the factorization of quadratic expression. If you found this beneficial, do seek out our other videos under the KT tutorial channel.